Joining us today is Wouter Hartman, Principal Geotechnical Engineer and Director, GEOHART Consultants, who will be speaking at IIR's UnderMINE Underground Operators Summit, 28th to 29th of June 2010 in Fremantle. Hello Wouter, thank you very much for joining us.
Good afternoon, James. Very well to speak with you this afternoon.
Can you start by giving us a brief background into the principles and current status of ground support and strata control?
It's fairly simple. We, in terms of where I sit, in terms of where other people sit, it's probably not that simple. I mean, all we know is that we drill a few holes in the ground and install, steel there and mesh, and voila, you've got a ground support system. But a fair amount of detailed work goes into that design. Now, there's a few people that currently looking at to steer away from the word design. I'm of the opinion it's obviously the wrong way, because we've got two scenarios where we provide advice to clients, and in general terms, people want to go the support selection way and provide clients with, okay, well, here's a support system that will provide you with the necessary ability or capacity to do the work. But naming it support selection, I would say, is the wrong way, because we've put in a fair amount of detailed work over the last 20 years to come up with the word design in ground support systems, to not continue with it in the terms quasi and static for static loading conditions. Now, I agree there's concern about the actual ground support capacity and dynamic conditions, but I think, where there's also significant amount of work that's been done over the last 15 years in terms of ground control in dynamic situations. And in terms of that's where I sit not on the fence, but I say we stick with the word design, because I think it's fairly valid for our discipline. Although the word ground support selection is also valid, but you need to go through a support selection criteria to identify a support, and then you make your decision based on the information that you gather, either through an area where you've identified a mechanism of failure, where you've clearly identified that mechanism and you clearly understand that your ground support can withstand any dynamic or quasi-static loading condition.
And what are some of the latest technologies being employed by the mining industry, both natural and artificial?
Well, we've gone through a process of the natural way to support ground is by leaving pillars intact in your ground by means of not mining or just leaving unmined areas. And that will support your immediate ground and also support for regional stability in your mine. Now, it's also very much to do with the information at hand, so you need to have a good grip on your material that you're working with, whether you've done some stress measurements within your mine, or or whether you've got done some strength testing on the material at hand, and then you leave material intact, and that will probably assist you with the regional stability and local stability, with just leaving intact ground in place. Artificially, the latest probably technologies that we're looking at in terms of dynamic support is, we've seen as a reason in recent times, people using a chain link mesh or a diamond mesh, which could assist, because I think we've probably gone to an area where our normal stiff mesh won't last the distance, and probably won't provide enough cover or additional cover for the dynamic conditions. And mines are getting deeper in Australia. It's no secret, and when going deeper, obviously stresses are increasing, and obviously the concern of dynamic motion and seismicity in your mine. So obviously the technology has moved forward on the backdrop of research done in other countries like Canada and South Africa, for that matter.
How can modelling be used to predict ground and roof support behaviour?
Well, that's two ways. Now, I've mentioned previously that we're working on the principle of dynamics and quasi-static environment. We've gone through the principle that at this point in time in the year 2010, that we see now the benefits of nonlinear inelastic modeling and real-time dynamic modeling. Now, there's a few products on the market that is currently available to engineers, but bear in mind they still need an experienced hand to lead people through it, because what you put in is what you get out with most of these models. So a model that I currently looking at is the Alphen code, which is it's a hybrid finite element analysis code, which is quite a superior product in terms of looking at ground behavior and also roof support behavior in terms of deformation around the excavations.
How can you control ground support costs, including initial costs, rehabilitation costs, and early integrity testing and detection technologies?
Well, James, the main thing is there in terms of controlling ground support. You gotta know your environment. Now, I think there's enough written in majority of cases that will lead you into controlling those costs in terms of the correct selection of ground support for that specific condition, or the best interpretation of your ground behavior. Now, that can only be done if you've got enough information. Now, if proportion of your budget is spent on finding out how your ground will behave, then you will end up selecting the best ground support, and obviously your initial cost will probably be a bit high, but then obviously that will negate the option to go back later on and do some rehabilitation. Now, in terms of that, the early integrity testing detection technologies that's now available is of great value to mining companies, and also would probably, where I sit, will probably get into the area where the support companies, the ground support companies, will get into a position where they will supply that service to mining companies in terms of quality control. And also, once you've got an idea in terms of corrosion, where your ground support is subject to corrosion, you can now easily take whether your ground support or your rock reinforcement has been either subject to corrosion, and the integrity of that subsystem has been compromised. And then by using these technologies, and also the early detection of the integrity of your system that's been compromised, you can now ensure that production won't be halted by an unforeseen large groundfall, which will either stop production or will end up in either injury or fatalities.
You're speaking at IIR's UnderMINE Summit 2010 on the 28th to 29th of June in Fremantle. What will you be discussing in your presentation?
Well, what we'll be discussing is our ground support in general in terms of natural support. I'll go through a background on ground support, either natural or artificial, and we'll go through some of the benefits of using an area where we use underground pillars for stability, either in metalliferous or coal mining, for example. And also going through artificial support and looking at sort of new technologies that's become available to the mines and engineers to choose from. So pretty much, a bit sort of wide, but pretty much looking at ground support in general, and also looking at integrity testing of ground support. I'll be looking at that in particular at the end of the talk.
What do you hope events like this will achieve for the industry?
Well, I would certainly hope that will attract some attention, especially from people that's closely associated with the industry, and also people that never had, especially from a contracting point of view, and also the mining people, engineers in general, non-engineers, to participate at a forum like this, and also, learn something. I would hope learn something new, or maybe just refreshing the old archives.
Wouter Hartman, many thanks for speaking with us today.
Thank you very much, James.